Welcome to S Chemistry. I'm your instructor Dr. Suhas Gauri and I will be teaching BSc 5th semester Physical Chemistry course on colligative properties of dilute solution. Here is the outline. First, I will introduce about what is meant by colligative properties and what is meant by followed by what is meant by solution. Then we will see what is meant by electrolytes and types of the electrolytes as well as non-electrolytes also. So let's start with introduction. So colligative properties means the Greek word is actual Greek word is that is originated from the colligates. Colligates means the collected together. So here we are collecting together the solid particle into the solution. Let's see the definition. What is meant by colligative properties? So colligative properties are those which depend entirely upon the number of particles of the solute dissolved in known volume of given solvent. So here you have two part of the properties. You have one solid, another is solvent. So colligative properties are those which depend entirely upon the number of particles of the solid. So how many particles of the solid is there? Based on that, your colligative property is dependent on the for that corresponding solution. So here solid quantity of solute is always less than the particle of or molecule of the solvent, and not at all upon the nature, that is the chemical composition or constitution of the solute. So here we are not considering the all the nature of the chemical composition or constitution of the solid. So let's see what is mean by pure solvent. So here as you can see in this diagram, here pure solvent, this is the beaker and you have this liquid particle of the corresponding solvent. So some of the this is in liquid state and above is in gaseous state of that same solvent molecule that goes in gaseous state at particular partial pressure of like 1 atmospheric pressure. So here is the example of solvent with solid. So here red spot shows that it is a solid particle and blue is showing the solvent. So this is a mix in the beaker. So this line describes the solvent line, below that solvent and above one is the gaseous state. So this is liquid and this is gaseous. So due to vapor pressure you have solvent molecule in the air. So here is the solute is invariably taken as a non-volatile. So solute particle not shown on the top of that solvent barrier, that this indicates that it is a non-volatile compound. So we always invariably taken as a non-volatile solute. Now we will see the what is meant by solution. A solution is defined as a homogeneous mixture of two or more substances having uniform properties throughout. So this is your solution is made up of actually more than two or three substances. So it should be homogeneous, that is the first criteria, and second criteria it is should be made from the mixture of two or more substances. And that property should follow whatever the solution is following the same for properties, that should be uniform throughout. So that it is the third condition. So solution can be made using solvent plus solid. So here is the example of solution where H2O, that is water, if you take NaCl into the water, we call it that is a binary solution, because you have two component or two substances in the mixture and that is homogeneous. That's why we call it binary. Bi means two. So one is solid, another is solvent. So next example is ternary solution, that is water plus NaCl plus sugar. So NaCl is mixed with sugar and whole which is soluble in water. So if this two solid is soluble in water, we call it ternary solution. So both are homogeneous. The third solution is your quaternary solution. So in this case we have taken sodium chloride, sugar plus lemon into the water. So this make is a quaternary solution. So this is the type of the solutions. So now we'll see the what is meant by component. So number of substance or compound in the solution, we call it components. Suppose take example um, A plus B, so it forms the A plus B solution. So A is a solid, that is solute, B is a liquid, that is solvent. So together it will form a homogeneous mixture that should be in liquid state. So this is the one example of solution. So another example is A plus B equal to A plus B. So here you have another condition. Suppose you have a solid that is in major quantity. Consider as a take as a any like azeotrope or zeolite. If you put some liquid in zeolite, so your major component will be solid. So that is also one kind of uniform homogeneous mixture, but your state of that solution will be the in solid state. So your A plus B will be the solid state. So this is the two types of the one sol in one case solid is minor, or so so solid component is a in terms of quantity is less, and one is in another case your liquid is less. So that's why we get two types of the solution. So now we are going to moving to the third point, that is electrolytes. So we will see what is meant by electrolytes. So first is the definition: a substance that dissolve or dissociate in water or other polar solvent to produce ions. So a substance, so electrolyte is a substance that dissolves or dissociate in water or other polar solvent to produce ions. So solution that conducts electricity. In general, if molecular compound is made up of using metal and non-metal atoms are said to be electrolytes. So here first condition is your solution has to be conducting. So it should conduct electricity, that is the first criteria. So we call it electrolytes. In general, if molecular compound is made up of using metal and non-metal atoms are said to be electrolytes. So if you are in compound, you should have non-metal as well as metal atoms. Then you can say it's a general say it's a conducting electrolytes. For example, your strong acid and bases, soluble salts, weak acids and bases, slightly soluble salts. So these are the examples. Now we are going to see the examples of the strong electrolytes. What is meant by strong electrolytes? So here HCl is there. Another example is H2SO4. So these are the strong KOH, calcium chloride, that is C CaCl2. Another example is sodium nitrate, so NaNO3. So here you can see there are two components are there. One is metal, another is non-metal. So in terms of HCl, so in both cases are non-metal components, hydrogen as well as chlorine also non-metal. So but also it forms the strong acid base, strong electrolytes. So because of highly soluble salts, these are the highly soluble salts. Another example is weak electrolytes. So here S3PO4 is there, CH3OOH. So this is the acetic acid, example of acetic acid. And third is iron OH3. So this is iron hydroxylate. So here three ions are there. One is metal, another is non-metal. So you can see it's a weak electrolytes. Now we will see what is meant by non-electrolytes. So let's start with the example, a definition. A substance that does not dissociate or dissolve in water or other polar solvent. So here your substance that does not dissociate or dissolve in water or other polar solvent, we call it non-electrolyte. So second point is a solution that does not conduct electricity, or you can say in another way, if your solution is not conducting any electricity, we call it as a non-electrolyte solution. So in general, if molecular compound is made up of using non-metal atoms are non-electrolytes. So in generally, so we call it using non-metal atoms. If your compound is made up of non-metal atoms, we call it non-electrolytes. So that is the example of completely covalent compound. So these are the examples like CCl4. If you dissolve in water, it will not conduct any electricity because both are the polar solvent, and it is not dissociate into the ions. So that's why water is not will conduct electricity. So that's why it is a non-electrolyte solution. If your methanol, if it's soluble in water, that is also one kind of non-electrolyte solution. So these are the examples of covalent compound as well as its solid particles. So here we are, these are the examples of the solid substances that is a solid, but which is made up of the covalent compound. So C4H10, so this is another hydrocarbon. If you put in water, so it will not dissociate. That's why it is a non-electrolyte substances. So here we come to end of this lecture. So these are the references I have followed. So this is the books I have followed for these lectures. So thank you for kind listening. See you in next lecture. Till then, happy learning.